Hi guys, welcome to section 8.8. This is your last section in the trigonometry chapter. So start with your only one warm-up problem today and we will get started with your notes. All right, number one is finding the area of this right triangle. So you had to use SOHCAHTOA to find one of these side lengths for your base and your height. And then you simply just plug it in to your area equation to find the entire area. Again, when we are rounding, we're getting a lot of decimals in this chapter. When doing so, just make sure you're always, for intermediate computations, rounding to the 4 decimal places at the back end, and the final answer you round to whatever it tells you to. Again, typically it is to the 10th place. All right, so that is an easier type of area triangle problem because it is a right triangle. You know what your base and your height are because they always hug the right angle. But what if we were trying to find the area of a triangle that is not a right triangle? So you can see these next couple problems are not right triangles, but we're still going to be asked to find the area of it. So what we need to do is find or make a right triangle by drawing a height. So we're going to draw like a little dotted line in these triangles to do that, because using that we can use SOHCAHTOA again. So it tells us to round our answers to the 100th place, and then round again your intermediate computations to 4 decimal places. So you have 2 types of triangles. If it's not a right triangle, then it's obviously an acute triangle or it is an obtuse triangle. So if you have an acute triangle, as you can see in number 1, we're going to draw the height from the longest side to the opposite vertex. So this should be inside the triangle, okay? Versus the obtuse triangle, you're going to draw the height from the longest side to the opposite vertex. This one is going to be outside the triangle. Okay, so I'll show you what I mean there. All right, so for number 1, obviously we're finding the area. So we'll just write down the area formula, 1/2 base times height. So now we're like, okay, which one's the height? Which one's the base? Your base is always the longest side of what they give you. So this is your base side, 11 inches. Okay, so basically your height and your base always connect, right? So this triangle is sitting, or it should be sitting on that longest side. So to draw a height, you're going to draw a height from that longest side to the vertex opposite that. So this is the height of, like, again, think of a triangle as a mountain. This is the bottom of the mountain, and then the height is going to be this part. All right, so now we found a right triangle, and now we're going to be able to use SOHCAHTOA to solve for this missing length, which we'll call x. So 11 is this entire base length. We don't know how much this is. This could be 7, 6, 8. We have no idea. So you really can't use 11 in your problem right now. So if you need to like scratch it out so it's out of your brain, do so. But now we're solving that triangle up top. So you have 38 is obviously your perspective angle. This is going to be your O, and we have our H, so we're going to be using sine. So sine of 38 equals x over 9. So x is equal to 9 sine 38, which is going to be the height, which is what you're going to plug in to your area formula. So a couple things here. You can plug in 9 sine 38 and get like those decimal answers and plug it into your area equation here. What I would do, just to make my life easier, I would just type in 9 sine 38, and then press equals, multiply it then by 11, press equals, and then divide by 2, press equals. Just so like all of this is in one calculation on your calculator instead of having to do this, press equals, then rewrite it into here, right? Just do it all in one shot, making your calculations way easier. And so again, I want you to try it, like pause right now, try to do it yourself, and you should get 30.48 inches squared. Again, so all these calculations I'm giving to you, I'm not taking the time to type it in because that'd be boring for you, but I need you to be pausing when I'm doing these practice problems and making sure you're getting it. Because again, it would really suck if you have all of this correct, but you just don't know how to use a calculator correctly on your quiz and your test. And unfortunately, you will get marked off on that. All right, so that's for acute triangles. Acute triangles draw the height on the inside. Okay, obtuse triangles are a little bit differently. The same sort of idea. Again, we're finding the area, so I'm just going to write your area equals 1/2 base times height. Your base, again, is always your longest side that they give you. So if this is a mountain, it's sitting on this 15. So 15 is going to be your base, and we're going to need to find the height. So the height on this one is always, again, you look at your vertex or the highest peak of that mountain and you drop it down. So this is going to be the height of this mountain. So we basically, again, you're drawing a 90-degree angle because you want to use SOHCAHTOA to solve for that height. Okay, so now looking at this triangle here, obviously, we have X, we have 9, but we need some sort of angle either here or here in order to do SOHCAHTOA. The nice part is that obviously they gave us this is 142. We can find the angle right next door to it because it adds up to 180. So you just have to do a little bit more work there and you will get 38. Okay, now that you have a reference angle, label your sides. This is your opposite, this is your hypotenuse. So again, it will be sine. And oddly enough, again, it is sine 38 equals x over 9, which is literally what we just did above. Very rare that's going to happen. That's exactly the same type of numbers. So that is definitely a coincidence. Don't get used to that. So 9 sine 38 happens to be the height again on this problem. And again, I would do the same thing where you're plugging it into your calculator. So type in 9 sine 38 equals, multiply that by 15, equals, divide by 2, equals, and you should get 41.56 inches squared. So pause here, do the next one all by yourself, and then return back for your answer. All right, number 3, you should get 22.98 or meters, I should say, squared. All right, so the hardest part of this chapter, I would say like algebraically, because it can get kind of confusing. We did law of sines. Now we're going to do something called law of cosines. So it could get a little bit ugly if you're not strong with our algebra skills because it's going to look messy, but I'm going to try to explain it as best as I can for you guys. So law of sines had different procedures and when to use law of sines. Law of cosines you use with triangles that give you SAS and give you SSS, okay? So that's the only time you use law of cosines. Again, always try to use law of sines first. That's way easier than getting to law of cosines. Law of cosines is like when it's the worst of the worst. So here are your equations. Honestly, obviously, you can see that it's the same equation, just repeated 3 times. I just memorize this first one. And then the B and C are kind of the same thing. They're just obviously interchanging A, B, and C together. So here's your equation you need to have memorized. A squared, so this part's easy. A squared equals B squared plus C squared. That runs you Pythagorean theorem, right? And then it's always minus 2, and it's always these 2 letters repeated. So BC, BC. And then times cosine, whatever this little a was, this is big A. Because remember, on triangles, when we label them, the capital letters are your angles, and these lowercase letters are referencing your side lengths. Okay, so that's kind of how I memorize it. So Pythagorean theorem, minus 2, these letters are these letters, and then whatever this letter is should match with this letter. Okay, so how does that look when we're actually doing it? We're not going to get to one of these today, but this might happen in ALEKS. If you are solving a triangle that gives you all 3 sides for an SSS triangle, you must solve for the biggest angle first or the formula will break down. So that's like a quick little hint there. Again, we can't decide when's going to happen. It just happens in ALEKS, sometimes, sometimes not. Just make sure you're prepared for if it happens in ALEKS, please solve for the biggest angle first. All right. So the deal with law of cosines is it's a really big problem that I keep on anticipating you to say, because you're first going to use law of cosines one time to find something that's missing, a missing side or missing angle, and then you also are going to use law of sines to find the rest of the triangle. So it's a really good, obviously, big problem I could put as a free response problem because you're going to use law of cosines, and then you typically have to use law of sines after. So it's a big problem to solve the entire triangle. All right, so let's get to it. All right, so you have this triangle and it gives you plenty of things. So again, big capital letters are degrees. So this is 98. And I'm not using a triangle that's drawn to scale or anything. I'm just, if you can see all these problems, it's the same triangle repeated over and over. So don't say it looks like 74 or anything like that. It's just a random triangle. All right. So here's what they gave you. So again, you can see that it is an SAS triangle. Obviously, we know we're going to use law of cosines, but pretend this was on a test. How would you know? So this was a SAS. We're going to be using law of cosines. So what you do is, and I'll write down the formula, a squared equals b squared plus c squared minus 2bc cosine a. Okay, so again, kind of ignore the a's and the b's and the c's in reference to these a's, b's, and c's. I'm not really following that. What I look for is, we're going to obviously solve for this missing side, or actually referenced out, really nice. Okay, so we're going to go with that side. So I'm going to plug in everything I know. So this will be a squared equals, and then the two other sides, so 38 squared plus 74 squared minus, again, you repeat those two sides, and then times cosine of the angle of the side we're talking about. So again, little a, so you find the angle across from it, cosine 98. Okay, looks very long and complicated, things that we haven't gotten to really yet, but again, let the calculator do all the work for you. So a squared, if you're really good with your calculator and you can use parentheses very efficiently, you can all do this in one bit. If you're using a calculator to try to do all at once, I would put these, or use parentheses on your calculator. I would put parentheses around that, and I'd put parentheses around here. Okay, but the safest way to do this would be, I would do this first. So I would type in 38 squared plus 74 squared equals, and I would get 6920. Okay, I would drop down this minus sign, minus, and then I would do all this work, 2 times 38 times 74 times cosine 98. Okay, that it happens to be a negative number. Sometimes it'll be positive, but you have to be very careful with your signs here. And again, round to 4 decimal places. Okay, and then I would just do a second calculation. Now I would type all this into your calculator, and you should get a squared equals 77027095. Take the square root of that, and you should get 87.8. Okay, so as complicated as it looks, all the math should be done in your calculator. So making sure, again, if you want to try again to do this all in one little batch, in your calculator, see if you're getting 87.8. If you're not, then again, I would break it down nice and slowly like I did there. But we aren't done. So that gives us at least one side. So we have all the sides solved now. So we have 87.8. But now we need to solve for the missing angles. We still have B and C to solve for. So what are we going to use now? We're going to use law of sines. So I'm going to get a different color. So I'm going to solve for angle B. Again, it doesn't matter because you have enough information for everything. So if I solve for angle B, I'm going to do angle B is across from 74. So 74 over sine B. Now with the side we just found, 87.8 and 98, I can set up the other side. So 87.8 over sine A. And now we have everything set up to solve for, oh, I didn't mean sine A. Obviously, we know what A is. A is 98. Okay, so 74 sine 98 equals 87.8 sine B. So in our calculator, if we divide both sides by 87.8, again, I'm going to rush through the sine part because you guys should know law of sines by now. So in my calculator, I should be typing in inverse sine of 74 sine 98 over 87.8. Okay, and we should get, for angle B, 56.6. Okay, that's what should go here. And the last part's the easy part because now we could solve for angle C because we know that a triangle adds up to 180. So we could just use 98 and 56.6 to quickly find that last angle. And last angle C will be, I have yet to do it myself, so 180 minus 98 minus 56.6, and you get 25.4. Okay, so this is why it is a really good problem for me to put on a test, because you have to do cosine, law of sines, and then obviously just add to 180. So these end up being long problems. All right, number 2 is a little bit of a different one. This is also a really good one to practice, because this again is where people who are a little bit weaker in their algebra skills will really mess up a law of cosines problem. So here's what I mean. So let's label your sides. You have 62, 66, and 26. So this is an SSS problem. So that means we are going to solve for, like I said, the biggest side. For SSS, you must solve for the biggest angle first. Okay, so the biggest angle on this one is going to be angle C. So it's across from, because we know that because it's across from the biggest side. Okay, so what we're going to do is set up SOHCAHTOA in that way. So we're going to do 66 squared equals the two other sides. If you're confused why I put 66 first, I'll show you in a second. Minus 2, and then remember you repeat those two ones you just wrote down, 26, cosine C. So remember we're solving for the biggest angle first, so the one that's across from it has to be, that's why I put 66 here, okay, because remember these two are matching. All right, so then we get to solving for that. So 66 squared is 4356. Again, we want to be very careful. This is where this particular problem is where we get really careful, and I'll show you why. So 4520 minus, then I want you to just do 2 times 62 times 26 is 3224. And then obviously we just write down cosine C. Here's where big algebra issues happen. A lot of students are going to do this. 4520 minus 3224 and try to combine like terms like that. That is so bad. We cannot do that. Again, pretend cosine C is just like an x. If this was like 3 equals 4 minus 5x, you guys would never subtract 4 minus 5x, or you shouldn't, right? If you were to solve this problem, what would you do? You would bring over the 4 first, and then you would divide by the negative 5. So same idea here. We're going to subtract this number first. Okay, so subtract minus 4520. So we're going to get minus 164 equals negative 3224 cosine C. Now you can divide by minus 3224, and you're going to get 0.0509 if you round to 4 decimal places, which seems accurate because we know the cosine of a number is going to be a decimal, and now you're just going to use that inverse cosine to find your angle. And rounded to the nearest 10th place would be 87.1. Okay, so you're going to get 87.1 for angle C. Again, now we can use law of sines to solve for any of the other angles. It doesn't matter at this point. We'd solve the big one first, but now we'll just solve for the other angles. All right, so I'm going to use, so we're going to obviously use these two together because that's going to help us solve the problem. So 66 over sine 87.1. I'll just solve for angle B. So we're going to use 26. So 26 over sine B. And now we are off to the races to solve for that one. So 66 sine B, cross multiply, 26 sine 87.1. So in our calculator, we're going to use your inverse sine, divide. So 26 sine 87.1 divided by 66 is what we should be typing in the calculator. And we should get 23.1 as our answer. So 23.1. And again, now we just are going to use basic 180 type of math to find angle C. And we're going to get angle A, 69.8. Okay, so try number 3 all by yourself and then come back for your answer. All right, C, you should get 50.0 as your angle C. And then make sure you have everything else, 57.1 as your side A. We were missing angle B, 69. And that's all you had to do there. All right. Yes, okay. I forgot if there's any more we have to do. Okay, so for the word problems, again, just like signs, some of them are hard and some of them are pretty easy. So, for example, this first one's not too bad. So based off the information they gave you, you can see it's SAS. So write that down, and then it should pop in your head. Okay, we're doing law of cosines. So we're solving for the length of the tunnel, which is right here. Okay, so we're going to call that x. So let's solve for it. So we get x squared equals, we're going to do the other two sides, 214 squared plus 166 squared minus 2. Repeat those two side lengths. Cosine of that angle, 72. So again, we should kind of be a little bit more comfortable writing the formula at least now. Now we just have to dive into calculating all that. So x squared equals, if I type in this, I will get 73352. Put the negative sign down, type in this. So again, these are the easier versions because it doesn't have that cosine angle. These are the easier versions versus if you don't know this angle, that's when you have to be very smart about your algebra. So x squared equals 51396. We do 4 decimal places and we take the square root of it and you should get 226.7 meters. Okay, and since this is a word problem, it didn't ask us to solve for the entire problem. So sometimes the word problems are easier because you just had to do one thing and we're done, right? The other ones were harder technically because you had to solve for everything. So we kind of like word problems, especially with law of cosines where these can get pretty long. All right, last one, and a good one. I would hint on a test because some complicated things happening here. So it says a ship leaves port A and travels 66 miles west. It adjusts its course 32 degrees north and travels 84 miles in that direction. So you guys can see what the drawing is. What angle, this should say theta, with respect to north, could the ship have traveled to directly go from A to B? So instead of going here, we're trying to see what angle it could have done there. So we're solving for this angle first. But what we're going to do strategically is actually solve for this angle because it's inside the actual triangle. All right, so how we're going to do this? We are going to need to find this length first, okay? So we're going to use law of cosines. Okay, so what we're going to do is this is going to be 148 on the inside because now this is an SAS triangle, right? SAS. So now we could use law of cosines. So we will call this x. Okay, so now set up your cosines. X squared equals 84 squared plus 66 squared minus 2. Repeat those two. Okay, and then we do the math here. So I'm doing the first two parts. We will get that number minus, and again, sometimes you do get a negative number with the other one, totally fine. Sometimes it'll be positive, sometimes it'll be negative, so don't freak out if it's negative, it will happen. Add those two numbers together, you get 2008, 8427. So x is going to equal 45. So now that we know that this is 45 here, that's now going to help us solve for this angle here, okay? Because then if we have this angle, we can just subtract basically from 90 to find that missing angle theta that we were looking for. So now again, after law of cosines, what should I be using? I should be using law of sines. So I'm just going to call this angle here angle A because it's next to port A. So now we're going to use law of sines to find that angle A. So I'm going to let you, actually, I'll pause here, let you solve for angle A first, and then we'll return back for your final answer to get angle theta. All right, if you set up angle A correctly, I will show you your how you should have set it up, but then you will solve it by yourself. But you should have set it up like this, and you should get angle A is 82, which means theta needs to add to 90, so 90, or angle theta. So 90 minus 82. So that angle would be 8 degrees. That is how the ship could have just turned 8 degrees to the left or west to just go from A to B. Again, a very excellent test question because it involved cosine and sine and making sure you're logically being able to solve for the missing angle theta there. All right, so let's practice some problems on Alex and let me know if you have any questions.